because you always knew how to, or you always were able to solve for x. And yesterday, the reason why you were able to solve for x was because, dun, 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 that fundamental theorem of algebra. Okay? And what we were getting towards yesterday with all the polynomial stuff was that as you go through them, we had a whole system in place of discussing. We talked about nth degree polynomials had nth number of possible zeros. We had X amount of terms in our sequence. We had changes of directions. We had dance moves and things like that. That's what you guys should do. You guys should do dance moves for the dance team stuff. Like literally the math dance moves. You know there's more dance moves? There are. Yeah, there's the sine. Oh wait, no, I'm sorry. This is sine if you're looking at it. This is cosine, tangent, cotangent, secant. All right, so this is cosine. This is secant. We have there's a lot of dance moves. You guys, I think you should math it. I don't think they're going to do it. I don't know. The dance pins? Actually, I'm sorry. This is tangent for what you're looking at. This is cotangent. I always forget that you're in front of me. I don't even know what's going on. All right. Anyway, so when you guys were working, I had you doing 25 through 34, I believe. Anything in particular you want to talk about? 34? Sure. What's different is that now we're finding all zeros, so you're going to have imaginary solutions. There really isn't anything different. It was just kind of like, why did everything work? Because he knows. All right, now in this one here, fourth degree polynomial should have 5 terms in the sequence. 4, 3, 2, 1. We do. We know that this one has tails that dance up, up, and away. See, I started feeling better. Okay. Okay, that's weird. So, plus minus a lot. So I'm going to go ahead and say that with a tail of a 160, you have plus minus of a lot divided by 1 or 2. What's that? If I ever ask you guys to list out everything, I'm not going to give you 160. But I could give you 160 because you would be able to find it by the time you would have to go through all that 80. So if you graph this one, yes, ma'am. Point of labeling out the factors so that way you know where to start. You know what to look for. So did you do that one wrong? All right. Well, let's show everybody what we did. And if by chance I have, a stroke of in this one here, what can you guys read out to me again? It was 2x to the 4th minus x to the 3rd minus 42x. And then, was there no x squared? Oh, x squared. All right, so in the graph here, so apparently it looks like we've got 4 zeros here. Obviously, we could go through the list and go through all of them. That's just a big pain in the butt. Why not just say, let's use -2 as a starting point? Okay. And if you think about it, if you were doing this the normal way that we would have started at 1, -1, 2, -2. We would have gone through the list like that anyway. So the -2 would have probably been the fourth one you tried. And like I said, I try not to make them any more than that as you're going through synthetic division, so that way you don't just get more so than normal. No, but thanks. It's close. It's close-ish. All right, so we have a 0 then at -2. As I go through it, would 3 be a possible 0? No. What's 1 plus 6? 7. Is that divisible by 3? No. So you check 4 then. And 4 works then. And now I'm at what times what's -40 add together to get 3? This one? Yeah, I didn't think of that one. Good call. So did you take your phone from me to do that?
Tell me take her phone too, and then turn off all the alarms.
It's gonna go off again in like 10 minutes. Right? If he's like, it's not gonna go off in 10 minutes. It's gonna go off at like, no, try not to do it. We're gonna probably go off at like 11:30 today. But no, that's faster. At least it's not an alarm that yells, "Get out of bed, you dope!" Like that. So those are your 4 zeros. So other than that one, what, was it terrible? So let's add a couple of problems to this tonight, because what I want to do is talk about working backwards. Okay? And when we work backwards with this, you guys know that we've been doing this all along. For example, if I say that if you have a 0 and 2, what's your term? X minus 2. If I say you have a 0 at -4, what's your term? X plus 4. So all along, the idea of the relationships between zeros and terms, we've been talking about the whole time. It's that planting the seed of knowledge that you guys have meandered about through. And there is reasons why we say things the way we do. So, for example, again, duck food.
Important, very important.
Throw the. It bounces. Later. So, remember what zeros and terms? Yes, yes, yes. So, what happens here? Write a polynomial function of least degree that has real coefficients given the following zeros and a leading coefficient of 1. So that's a whole mumbo jumbo of the following. If 3 is a 0, what's its term? If 0 is a 0, what's its term? X. You're right, I heard you say x minus 0, that's fine. If -2 is a 0, what's its term? X plus 2. Couldn't you just multiply all that? Here's working backwards. You've done this work. You just didn't realize you've been doing this work. Okay? With all the words up top, write a polynomial of least degree. That means if you have 3 zeros, what should be your degree? 3. Third degree polynomials generate 3 zeros. Leading term coefficient being 1. Well, that's helpful because you don't want to deal with all the really crappy fraction stuff. Yeah. Okay. We're not going to worry about making that first term not 1. We could, but it's not terrible. Okay? I'll show you the difference between when it's not equal to 1 in a couple examples. So again, if 3 is our 0, that means my term is x minus 3. If 0 is my 0, that means it's an x. And the other one would be an x plus 2. Now, if I go to FOIL all that out, or multiply all that out, which two would you multiply together first? Yeah, do the x minus 3x plus 2, because that's a generic FOILing problem. If I do that, I'm going to get x squared minus x minus 6. And I multiply all that by x. Here's your polynomial. Remember, when you're multiplying things out, the order in which you multiply doesn't matter. You could have multiplied the x into the x plus 2 and then FOILed it out with x minus 3. It doesn't matter because 3 times 2 times 4 is the same thing as 2 times 2. That's the same thing as 2 times 3. Or 2 times 4. It's crazy about that. What do you want? It's definitely not a factor. If the leading coefficient wasn't 1, I would say, let's say you had a 0 of, oh, we just had one like this. We had a 0 at 5 over 2. If I had a 0 of 5 over 2, what could you generate? There's two different ways you could generate a term for that. One of the terms you could have made would have been x minus 5 halves. Or, if you think about it working backwards, wouldn't that have been 2x minus 5? For a 0? So that's the reason why they put in the idea of leading term coefficient 1. So if you do see a fractional 0, you treat it as just x minus it or x plus it, as opposed to rewriting it like that. Does that make sense? So if I say that, if I don't put in the leading coefficient equal to 1 on there for you, and I give you a fractional 1, you just have to backwards like you would for what term generated. Does that make sense? More often than not, the book does leading term coefficient 1. I've been known to say it once in a while too, but no, it's not that bad. You got one? We did. Yeah, it's a lot of things. Why is it so fucking hot in here? that. We'll do that last bit on Monday. I'm not worried about that. And even though. Oh yeah. Sorry. Hey guys. On this one here, do the 36 to 46 even, but no 44, but do 43. How's that? All right, we'll go from there. That way you've got a couple of the practices with the imaginaries and stuff to go out. Yeah, we'll get to we'll explain why all the complex number one. It's a really weird scenario, and it does take time. And we don't have enough time to finish that one out. I kind of screwed around. I'm sorry. Seriously. Is that better?